Audio Engineering 101. When you're doing audio engineering, the first thing that you want to make sure is that you do not clip your tracks. Clipping occurs whenever the signal raises above 0 decibels. 0 decibels is pretty much an arbitrary cutoff to how loud the signal can be, or the waveform, before it stops capturing the height of the slope or the height of the curve. The second is that you want to mix your audio so that way the things that you want to hear, like background noise and the noise of someone's voice, are at nominal levels. Final thing is you then raise all the volumes of all your levels so that they're nominal and can be played on different devices in different scenarios. In this video, I'm just mostly going through trying to show constructive and deconstructive interference, which is the bane of audio engineering. What is constructive and deconstructive interference, and how can we visualize it?
I'm going to have to sample the frequency of the audio output from my computer. I don't want to destroy any of my other cables. I don't necessarily want to buy a cable for this. I just need it to display the audio output. So this cheapo XLR to stereo headphone jack, which is interesting that this is stereo, because this XLR cables are not stereo. This is what we're looking at. We're looking at the head of an XLR jack. So if just unscrew that screw and open it up, we see that there is 3 wires on this. So we only have two items here. One is the shielding wire, and the other is the signal wire, which is going here. And the shielding is also grounded. I thought there could be a third wire because the other end of this is a stereo headphone jack, which has 3 sections, 1, 2, and 3, so left to right and ground usually. But I'm going to tap right into this by taking the gripper and just attaching it to the signal, and then I can take the ground wire and stick it right on here. We're also going to put some padding down. Neoprene foam has been godsend. So there we go. So now instead of the yellow back, I'm cutting the wire. Now I have to find my silly wire that I made earlier. So I just wanted to show, this is actually showing the output. It doesn't look exactly like the output. There we go. That's what we should be seeing. Alright, so we're seeing both of those waves together. So now they're both equal. No, they're both half in phase. Now they're both equal. So if they're both hitting each other at the same time, the height is increased. If they're the opposite phase, like you see here, it's 0, and that's the 0 output. It's a real oscilloscope output. But what's interesting is let's keep them in phase, but we're going to change the frequency so they'll rotate in and out of phase. So this is where it's kind of cool, and you start to get these interesting out patterns. So what you're looking at is constructive and deconstructive interference as displayed on a single mono output from 2 frequencies emanating in an audio signal. What happens if the waveforms are in the exact same phase and the same frequency, they will double each other, so they'll get twice as loud in amplitude. If they are out of phase, like completely out of phase and opposite, they'll cancel each other out. This is how noise cancellation works, usually on headphones and things like that.
is you just reproduce the exact sound that you're looking for, but invert the phase, and then it will cancel each other out if you apply the math together. Audio is kind of complicated. The biggest problem with audio, constructive and deconstructive interference, I give it a 2 on the scale of how bad it is. What's more important is to not clip, because anytime that you're recording audio digitally or even on an analog tape or a different medium, usually there is a clipping factor. So audio is measured in decibels, 0 decibels being the loudest something can be before it distorts, and kind of negative infinity. A human start to hallucinate auditorially if they're in a room that has like negative 48 decibels or below, and because you're so used to hearing background noise. The problem with signal decibels, which is different than specific pressure decibels, one, they're inverted. So signal decibels are 0 to negative, and then pressure decibels are 0 and to positive. They're both logarithmic in nature. So are frequencies. If you double the frequency, it raises the octave. If you increase a volume by 10 decibels, it will double in volume roughly. These are just based off of human perception. The sound levels and the logarithmic nature of sound levels are a little bit more subjective than the frequencies. Almost most, I don't know of any human that doesn't perceive a double frequency as a pitch shift higher an octave, but it's always possible. So yeah, so this video is pretty cool because we're looking at constructive and deconstructive interference, which happens in rooms. As the sound bounces off the walls and comes back, the microphone is going to pick up the main source. It's also going to pick up the reflection as my voice hits the wall. The perturbations in the air density hit the wall and then are reflected back. So you want to be as close to the microphone as possible, so that way you have a higher signal to noise ratio. You also want to keep your levels below the clipping value, because anytime that your clipping value raises above that 0 decibels, or that equipment is not meant to go higher than, you're going to chop off the top of the wave and you're going to lose information. It's going to be a lossy recording. So the tip number 1, and this is a good representation of audio, is try to be as close to the microphone to avoid the constructive and deconstructive interference. Try to keep your volume below 0 decibels. I personally like to set my levels at -3 as the highest sound when I'm recording on the input, and I try to have my sound B traverse the level -9. So this is a pretty much good audio for just vocals. Vocals are unique because vocals happen at a certain frequency. That frequency is kind of all over the place. If you look at a parametric EQ, if you look at an equalizer, and how equalizers show the information is crazy awesome. So you should look up Fourier transforms. Yeah, they're just epic. I'm going to leave off here. I have much more to do to show you guys, but I'm just kind of recording these bits for later use. Again, if you like my content, please like and subscribe, and check back later for even better videos.
You're going to see the pattern on the oscilloscope that looks like it. Yeah, so where these intersect with one another is interesting. Let's get one that's good. Yeah, there we go. Yeah, that's enough pontificating. So I don't know. I'm going to have to stop this video. Stop.